Hello, in this video we will talk about homogeneous constant coefficient equation which is inside of Engineering Mathematics 2 FEM 1023 in UTP. So guys, in this video we will talk about what is homogeneous constant coefficient equation, and we will look through some of the tutorial questions which is given. So normally let's consider a differential equation. By the way, I will try to use mostly the questions which are given inside the lecture slides, so you better understand if you don't understand like some parts. So equation given like this, a differential equation. So just this is differential equation, and we like without explanation, which is making it harder, we better go directly to auxiliary equation. So auxiliary equation, and here if you see a y double prime, we will write it m square. If it is y prime, it will be plus m, and y does not have any prime, so we will just write it 1. So here it has a, and for this it has b, and here it has c, which I just directly write c. So after we know the auxiliary equation, the only thing left to do the homogeneous equation, we need to find m. So how to find m in this equation? This is easy. First of all, you can find it on calculator easily. The other way is using the determinant. So the formula for this, it will be plus negative determinant over 2a. So what is determinant? It is b square negative 4ac. So let's do it. First we need to check the differential. So there can be three cases. In case 1, if the discriminant is bigger than 0, it means that we will have two real roots, m1 and m2, and they will not be equal to each other. That's one way. So for case 2, our discriminant can be equal to 0, which means that m1 is equal to m2, and this has one real root only. As for case 3, we have discriminant is less than 0, which means that the equation has not real roots, and we have m1 and m2, which is one of them is alpha plus I, which is complex number beta. For the other one is equal to alpha negative I beta. So after we know this, we need to find the answer for y, right? What is y? So this is the general solution for y, but we will not use this. This is general. So if, let's say, after we find m, and we found m1 and m2, and this is case 1. Let's say discriminant is bigger than 0, so we have different two real roots. The answer for y will be c1 em1x plus c2 em2x. If it is case 2, which is m1 is equal to m2 and discriminant is equal to 0, and it has one real root, so we will have y is equal to c1 emx plus c2x e over mx. So because the m is the same, we don't just like specify it. As for case 3, which has m1 and m2 are not real numbers, they are complex numbers. So it means that the discriminant is less than 0. So we will need to find what is alpha and what is beta. After we find what is alpha and what is beta, then we will write for y is equal to e over alpha x. My alpha looks like x itself multiplied by c1 cosine beta x plus c2 sine beta x. Yeah, that's it. So let's see how to use it. I'll just write the example 1 from lecture slides, then we go to tutorial questions. So in example 1 it says y double prime negative 36y is equal to 0. So we need to first write what? Auxiliary equation. Auxiliary equation, I just write like this. So because it is y square, it's second prime, like double prime, I write it is m square negative. Because y does not have any prime, we just write 36 is equal to 0. So we need to find the roots for the equation, right? So the roots for the equation, we cannot write m square is 36 and m is 6. Actually, like, you know, you can, but you will lose one of the roots, so this is not the way. I just delete it. The correct way is like this. We have a square negative b square is equal to 0, so a negative b, a positive b is equal to 0. From here we can go here. So I write m square negative 6 square is equal to 0, so m negative 6, m positive 6 plus 0, so m is equal to 6 and m is equal to negative 6. So looking by this question, by the roots, it means that we don't need to know what is the discriminant, but we definitely know that it is bigger than 0 because it has two real roots which are not equal to each other. So it is case 1. So what was y is equal to for case 1? It was c1 e over m1x plus c2 e over m2x. So we don't need to know c1 for now because it is not given. E over 6x plus c2 e over negative 6x. Yes, that is the solution and answer for the question. Let's go to tutorial 2.2, the question 1, for example. So it says y double prime negative 4y prime plus 4y is equal to 0. So we need to write the auxiliary equation directly, which is m square negative 4m plus 4, because it is double prime, which goes for 2 here. It has only one prime, I just write m over 1, and because like it doesn't have any prime, so I just write 4 is equal to 0. So we need to find the roots for this equation. Again, you can use calculator, or I normally use this method. To get m square, you need to multiply m by m, right? And to get 4, you can multiply 4 by 1, 2 by 2, like negative 2 by negative 2, or like many else. Not many, but like few else. But when considering this, we need to do it. Like if I write 2, so when I multiply this 2, it should make this. But when I multiply, when I add them, like this, m, like 2m, it makes 2m, right? And this one also, when I multiply, it makes 2m. It makes 4m, but I need to get negative 4m. So I choose to write negative 2 for both, and it will be my root. So m negative 2 square is equal to 0. But if this method looks confusing for you, you can just use your calculator or like your convenient method as well. So m is equal to 2 here. It has only one root, and this one root is real, so this is the discriminant is equal to 0 case. If you want, we can check it. Let's check it. Discriminant is equal to b squared negative 4ac. So what is b? B is negative 4 here in this equation. So negative 4 squared is 16, negative 4 multiplied by a is 1 and c is 4. And as you can see, discriminant makes 0. It means that it has one real root. So what was the answer for our real root? It was c1 e over mx plus c2 e over c2x over mx. So our answer will be c1 e 2 x plus c2x e over 2x. Yes, that's about it. Let's go to other question. I'll explain question 5, for example. In question 5, it says that y double prime plus y prime plus 3y is equal to 0. So we directly write the auxiliary equation, which is m squared plus m plus 3 is equal to 0. So from here we need to get the root. Let's get the root by calculator. Let me calculate. By the way, if you don't know how to use the calculator to find the equation, you press the mod on your calculator, then in number 5 it writes equation, then you choose the third one. There you write like the coefficients for the variables, and it gives us m1 is equal to negative 1 over 2 plus square root over 2i. m2 will be negative 1 over 2 negative 11 over 2i. So we need to decide what is alpha and what is beta. As you know, because this is case 3 and discriminant is less than 0, we can check it, but it will definitely come like this because we have complex root. So m1 should be like this, right? Alpha plus beta I. So looking at here, we can decide that alpha is negative 1 over 2 and beta is 11 square root 2, and there is no I. Yeah, so by looking this, we can write is y is equal to e over yeah, like we write e over alpha negative 1 over 2, it was our alpha, right? X c1 cosine beta, our beta is square root over 2 x plus c2 sine beta x, sorry, beta was square root 11.2 like x. So by the way, if you forgot, our equation was like this for the case 3. Y is equal to e alpha x c1 cosine beta x plus c2 sine beta x. Yeah, just like this. So this is the answer for our question. So easy, right?